morning everyone, welcome to my video. In this video I'm going to talk about RIP. My name is HCIE-Yuan. I'm the instructor for InfoSight. So let's start the lesson. So what exactly is RIP? RIP in short stands for Routing Information Protocol. RIP is an IGP, which means that it's an interior gateway protocol that running on distant vector algorithm. We have another algorithm which is a link state algorithm. Alright, so RIP is a distant vectors algorithm. RIP is mainly used in a small scale network and do not require high reliability. And is seldom used in a large and complex network. So if you intend to run some protocol on large and complex network, you should be running on OSPF or RSIs, which we are going to discuss on the few topic later on. Alright, so we focus on the RIP. We will look into RIP principle. We look into the RIP configuration, the RIP troubleshooting, as well as the enhanced capability of RIP. And we will also look into the RIP exam skill that is needed for you to pass your HCIE exam. So the content for our topic will be looking into the principle, the command, troubleshooting. We are going to discuss two cases on the RIP and look into the exam preparation. So first, we look into the principle on both RIP version 1 and version 2. We look into RIP timer. We'll look into some of the concepts such as a split horizon, poison reverse, and trigger update. And we will look into the route summarization, which is very important. And finally, we will combine all the RIP working process together. Let's first look into the RIP version 1. And even though RIP version 1 has been quite some time, let's look into the concept. And this is how the packet format of RIP look like. Now the top here, this will be our header, okay, which is in this case the command as well as the version. The command here we have two values, okay, so we have value number 1 or value number 2. Which value number 1 refer to a request and value number 2 refer to response. Okay, so we only have two values here. The version is either version 1 or version 2. This view is mainly as 0, not being used. We have address family identifier. Okay, this is for you to determine whether it's an IPv4 or whether they would like to request the entire routing table. So there are few values over here. If it's IPv4, it's a value of 2, and if you request for the entire routing table, it's a value of 0. This is not being used. So the IP address here is the IP address of the destination network. This two field is not being used, and the metric is the hop count that is used on the RIP. So generally, RIP is a classful routing protocol, which means that they will only look into the IP as a classful, like class A, B, and C. RIP version 1 use the broadcast mechanism for them to contact their neighbor. They are using UDP port 520 to send and receive packets. Now let's look into the RIP version 2. In RIP version 2, the format is similar to RIP version 1. Okay, except that you notice that there are some new fields. So route tag is a new. The subnet mask is a new field, and the hop count is a new field, the next hop. So the route tag is being used to determine whether the route has been imported into the RIP through the import command. So this is a subnet mask. As you notice that RIP version 1 doesn't have it because RIP version 1 is a classful, whereas RIP version 2 is a classless. So we do have a subnet mask information. We have a next hop here. If your next hop value is 0.0.0, means that optimum net hop is achieved. Else, that is not the optimal net hop. And the metric is similar to RIP version 1. Now, RIP version 2 uses 224009 instead of a broadcast for them to do update. they're using the same UDP 520 to send and receive packets. Now, as compared with RIP version 1, RIP version 2 has enhanced in the sense that they do support route tag, route summarization, CIDR, classless inter-domain routing, next hop, as well as authentication. And surprise, surprise, you notice that there is no authentication field over here. So there's a question here. Why do RIP 2 version 2 packet do not have authentication? Now, it all depends on your address family identifier. If you do have authentication field, this address family identifier will actually use to cater for the authentication. Okay, so we are going to look into some of the Wireshark capture for us to look into more detail. Okay, let's look into our Wireshark now. So here I have my Wireshark. So both version 1 and version 2. This is a version 1 Wireshark. As you can see that I have the response and I also have a request. Now if we look into our protocol here, you'll notice that we are using UDP port 520. And since this is a version 1, as you can see that this is a version 1, you'll notice that the method for them to communicate among RIP is using a broadcast. If I expand the routing information protocol, you'll notice that the header, we have a response, okay? And if you look into the request, you can see that the value is 1. We have a value of 1 here, which representing the version is version 1. So this is our address family, unspecified, which means that we want to get we're requesting the routing table. And there's the matrix. Okay, so this is our request. So we also have a response here. As you can see that the response here, we have the address family of IP, which is the value of 2. Okay, so this is version 1 on RIP. As you can see that the information here is pretty simple. Now, as compared to version 2, this is a version 2. And you notice that the version 2 is still using a UDP of 520. And they are using a multicast of 224009. Okay. Now, if I expand the routing information protocol, you notice that the format they are using is the same. So we have a command, we have the version. And if I expand the IP address, you notice that I have an address family. This is a new format here. Okay. The route tag. As compared to version 1, I do not have a route tag. This field is 0, meaning that they do not have any external route at this moment. I have a network mask here, as well as the next hop. All right. Now, these are the difference between a version 1 and version 2. So let's just go back into our slide here, and let's continue the next slide here. Let's look into the timer on RIP. Now, RIP is being regulated by 3 timers. The first timer is an update timer, second timer is aging timer, and the third timer is a garbage collect timer. Now, what's the relationship between these 3 timers? So let's look into the detail of the timer on how the mechanic works. Now, for example, I have R1 and R2. So these R1 and R2 are running both RIP, regardless on RIP version 1 or version 2, the mechanic is the same. Now R1 send an update to R2. Now upon receive this update, R2 is going to start the aging. Now the aging is going to count from 1 second all the way to 29. Now by the 30th second, the R1 should have a new update to R2. Now assuming that due to some reason, this update is not reachable to R2. Now R2 is going to continue the aging until 180 seconds. Now during the process of aging from 1st second until 180 seconds, this route is okay, it's still reachable. Now by the time of 181 seconds, it will go into the garbage collect timer. The hop count is become unreachable. Okay, so When we reach up to a 300 second, which is another 120 seconds from the aging timer, and when it first start go into the garbage collect timer, it will become unreachable, and once they go up to 301 seconds, it will go into delete. So in another word, when the aging from 1 up to 180 is reachable, from 181 to 300 seconds, this route is unreachable but is still inside the database. Right? So these are the relationship on all these timer. Now let's look into the split horizon. Now, definition of split horizon is a method of preventing routing loop by prohibiting device from advertising a route back to the neighbor through the interface that received the route. And split horizon is disabled by default if you are using NBMA. Now let's look into this example. We have R1 and R2. R1 have an interface of 10.00/8 attached to it. So 10.00/8 is a hop count of 0. Now R1 send this information, this update sent to router 2. Router 2, when you receive it, it will see this route as hop count of 1. Now if let's say the RIP on the R2 do not have a split horizon, it's going to send this information back to R1 to say that, hey, R1, I have a route of 10.0.0.0/8, and the hop count here is 2. Now, assuming that R2 also have connection to R3, it will also do the same thing, telling R3 that if you want to go to 10.0.0.0/8, you can go through me, and the hop count is 2. Now, assuming that that's happened, and assuming that R1 now lost the 10.0.0.0/8, and assuming that the split horizon doesn't work, so in this case, they do send back this information to R1. Now, R1 would think that, hey, I'm able to reach to 10.0.0.0/8, and my next hop here is R2. So I'm going to believe this update. Now, because R1 received this update and R1 also directly connected to R2, and R1 is going to add a hop from 2 plus 1 is become 3. Okay, saying that, hey, R2, if you want to go to the 10.0.0.0/8, you can come through me, and the hop count is 3. Now, R2, upon receive it, looking into the update, and the next hop is R1, and what it's going to do here is that it's going to add this from 2 to become 4, because since I received from R1 as 3, I'm going to send to R3 as a hop of 4, and I'm going to send this information to R1 as a hop of 4, and that is where the loop happens. Alright, so for us to prevent this loop, split horizon has to be enabled. Poisson reverse is a method of preventing routing loop, just like split horizon. But the mechanic it's used to do a loop prevention are slightly different. Now, they are sending what we call a poison, which is a hop count of 16, indicating an unreachable route, and advertise the route back to the neighbor. And poison reverse by default is disabled. Okay, so in this example, R1 send this information to R2. This information of 10.0.0/8 is a hop count of 1. Now, upon receive this information, where R2 enable for poison reverse is going to send this information back into R1, saying that the cost is 16. Now, when R1 receive this information, it will going to delete this information from the update. It's because that the cost is 16. All right, so the loop is prevented. All right, because I do not believe that R2 have the hop to the 10.0.0.0/8. So when both poison revert and split horizon are configured, only poison revert will take place. So please remember that under Huawei device, split horizon basically is enabled, and poison reverse is generally disabled. All right. Now, trigger update. Trigger update is a mechanic for you to shorten the network convergence time. And this is how it works. When the routing information changes, for example, in this case, the network of 10.0.0.0/8 attached to R1 changes from up to down, the RIP device is going to send this update to the neighbor immediately, which means that if, let's say, R1 just sent this information, let's say 2 seconds ago, and when this interface go down, it will not going to wait for another next 28 seconds before it's actually sent. It will never wait. It will just send immediately. Okay, so this is what we call the trigger update. And by doing so, you will reduce the time for the waiting, because if it's not, you are going to wait for 300 seconds before the route will be deleted. So trigger update expedite the convergence time. But over here, it's also mentioned that trigger update does not enable a device that receives the route update to reset its update timer. So which means that this information of 10.0.0.0 is failed. Now R1 is going to send this information to R2. Now R2, upon receive it, this information will not be trigger update to R3. Okay, so a trigger update is only happen between R1 to R2. Now, one of the powerful features of RIP version 2 is that RIP version 2 support summarization. And as we know that the summarization is very important. Routes that share the same next hop are destined to different subnet on the same natural network segment are summarized into one route that's being advertised to other segments. So in this example, we have 10.1.0.0 and we also have 10.2.0.0. Both of them are /16. Okay, now we can summarize based on the interface to use a /8 to R2. So R2, instead of having 2 entries, now they only have 1 single entry. So the summarization only can happen if you are using a version 2. And version 2 process-based classful summarization and interface summarization are available, which means that you can summarize based on interface, or you can configure based on the RIP config. Now let's look into the summary on how the whole thing work altogether. Now initial state is that when you start RIP, it will go into the initial state, and whichever interface that you have enabled the RIP will start to send or receive RIP, and RIP will build its routing table. So under this building routing table status, your RIP will be stable. Now during this process, I'm going to send and receive this routing update for every 30 seconds. So the entire routing table will be sent and received for every 30 seconds. If everything is fine, all right, the whole routing table will be stable. Now, assuming that the routing entry is more than 180 seconds, it will go into the garbage collect entry, and another 120 seconds, and it will go into the delete entry. Now, assuming that you have an entry that is attached to you and it go down, it will go into the trigger update. Now, once trigger update happen, it will go into the garbage collection, and 120 seconds later, it will straight away deleted. Now, if the condition of your route is under the garbage collect entry, that's the status, and you are still in the aging timer, but it's between 180 to 120, 180 and 120 garbage collection time, and assuming that the update came, now it will restore back your entry into your routing table. Okay, so this is the entire working process on RIP.
Thanks for watching. Please do not forget to subscribe to our channel.